All right, welcome everybody, and thank you for bearing with us while we worked out the login for the Zoom session and everything. Welcome to orientation. This is session A of session A and B. We actually, when we were putting together our orientation series, we wanted to do everything within 1 hour. There's just so much content. So this is the session A orientation, which runs every other week at this time. The session B orientation runs on off weeks at this time. This particular one is really useful for anyone new to N3C, whether you're a data analyst, sort of on a PI role or a clinician, but it's especially useful for those who are interested to learn about the data and the community at a high level to see if N3C is sort of right for your research project. Session B orientation covers more technical topics. So next week, we'll be talking about the actual tools and some of the methods that are used for analysis inside the enclave. Though this is a useful background to have in your pocket for that one, because we do talk about some of the data models and things in this orientation session as well. So N3C knowledge is really, really distributed, as you'll come to learn if you're not already familiar. This orientation really wouldn't be possible without the help of these subject matter experts and all of their help. Kristen, Devera, Emily, Arza, Tricia, and Alex, and Sean is me. And then, so let's dive in and talk about what N3C is all about. So the problem, of course, that N3C is addressing is that the US doesn't really have a central data, electronic health record data repository, right? In fact, we don't even have a standard data model or format. Different organizations use different systems. Generally, each organization has its own data warehouse, quote unquote, for internal use, whether it be for billing or whatever else. And these are often unique. You know, each hospital, each organization collects electronic health records a little bit differently for their own needs and uses. This isn't super awesome for folks who want to do research on electronic health records. However, so some progress has been made in the area of doing research on electronic health records across multiple institutions. And this is generally done so far by putting together what are known as research consortia networks, implementing what are known as common data models, or CDMs. These are sort of agreed upon methods for data collection and organization, right? And these are the kind of the secondary data sets that are often generated from those original electronic health record data that are generated for a variety of different purposes. Even so, there are several different common data models in use nationwide. Some institutions even participate in multiple of these sort of research networks. And for the most part, you know, if you're a researcher and you want to do work in electronic health records and you're wanting to work with one of these models, you kind of need to, you know, identify or associate with one of these research networks or partner institutions. So maybe you're affiliated with the PCORNet folks. And then you can identify a question that can be asked against that particular format and storage of data. And then you can sort of distribute your query so that it can run against all of these individual databases, which happen to have the same format. So your query, you know, will run in the same way across those different organizations. And then you can kind of take the results that have been run for you by those particular organizations and collect them back. And that's sort of a federated model, right? You distribute your query, someone else actually runs it against the data, and then you get the answers back. This has worked reasonably well, but it does preclude some things, right? Like you can't really do exploratory data analysis this way, and it precludes some things, for example, in the machine learning or other statistical models from being done with the kind of research that is available. So what N3C is doing is we're recruiting data partners from around the country to collect COVID-related data into a single unified database and common data model. This is a little tricky because all these source common data models are quite different. And even for a particular source data model like PCORNet, there can be differences between the sites in terms of how the data are collected and what data are collected. And so the process of sort of gathering all this different data from the different common data models and stuffing it into a single common data model is known as harmonization. And there's a really amazing team of N3C folks who work really closely with our data partners to make it happen. And so if you're potentially a new organization and you're interested in ingesting your data into N3C, know that there's some really great folks who are standing by to help you with that. This is sort of a harmonization from common data models to another common data model. So if you want to consider it, these common data models at the source institutions are a secondary usage of the data from the primary data warehouse data. And in a way, what we're doing is almost like a tertiary or third case use, because we're taking common data models and then putting them into a common data model. In any case, the target data model or format that we're using is known as OMOP, and you hear a lot about it in N3C because understanding OMOP is really the key to making sense of the data. But it is a learning curve for many folks if you're not already familiar with how OMOP, the database format, works. Now, because this is sensitive data, we can't redistribute it to researchers, right? We keep it under lock and key in a highly secure, what we call a secure cloud data enclave, to which we grant access to research teams with some fairly comprehensive access controls. And this turns out to be another learning curve because there are several steps involved in getting access to these millions of patients' electronic health records. And then lastly, because the data do live in the cloud, the tools to analyze it must be accessible via a web browser as well. The good news is that we do have the usual suspects like R and Python and SQL, and there are some surprisingly powerful graphical analysis tools if you're not like a high-powered coder. But as a matter of legality, we have to be extremely cautious of the data protection, even within this data enclave. And so literally every bit of data and code and all the actions that happen in the enclave are tracked. So in order to facilitate that, the interface is quite different than most data scientists are familiar with, right? So if you're familiar with Jupyter Notebooks, or if you're familiar with RStudio, those particular tools aren't available inside of the data enclave. Rather, there are some other tools that are available which do all of the tracking and provenance that are required for us to store this electronic health record data. So this actually makes for yet another learning curve. If you're familiar with those other tools, this is something else that you'll need to get familiar with. If all of these different learning curves sound daunting, worry not. We've got a lot of resources to help you get started, and the N3C community is incredibly friendly and helpful. So what's actually in the data? This is a screenshot of a dashboard. This is actually a screenshot from just the other day, so it's up to date. As of right now, there are about 50 data partners that we are getting data from, contributing data on almost 5 million total patients, about 1.2 million of whom were at some point COVID positive. Notice there's a little star there, and I'm going to put COVID positive in quotes because this, definition of what you consider to be COVID positive isn't super straightforward. In this particular case, we're counting all the patients who had a lab test, whether that be diagnostic, PCR antigen or antibody, or a diagnosis code of UO7.1, which is the ICD-10 code for COVID-19, which started to become prevalent in mid-2020. Data are pulled not for all patients from each data partner, but rather all of the COVID positive patients according to this particular definition, as well as twice as many demographically matched controls. And those are matched on things like pretty basic stuff, age, race, gender. I put controls here in quotes because it's worth keeping in mind, even though we're trying to get obviously as comprehensive of data as we can, these are not really random samples from any particular population, right? We have particular data partners, and not every institution in the US is a data partner. And so selection bias is something that you'll want to think about as you're working with the data in N3C. You may also notice that these numbers here aren't actually in a 2-to-1 ratio. There are many more non-COVID patients represented here in this screenshot, and that's because not all of the sites, and I should probably double check on this because I've been saying this for a while now and it could be wrong for a different reason, but at least at one point, not all of the sites had actually updated to using this 2-to-1 matched control data pull definition. What happens is over time, as the pandemic evolves, as the needs of the research community evolves, the definition of what data is pulled from the source partners can and does change. And of course, we get more and more source partners coming online to add more and more data to the database. And I mentioned this not necessarily to get into the details of all this, but to just note the dynamic nature of this data. It can and does change over time as the pandemic unfolds and as data partners come online. And in fact, all of the older versions of the data as it changes are available for reproducible research. So this screenshot is really just showing what's available in the current release of the data. But a release is made every week or two, and all previous releases are available for your work. So by default, when you're doing your analysis, you'll be working on the most recent release of the master branch of the data. But you can also always go back and do your analysis on a particular version of the data, and that can be really useful for reproducible research reasons and getting ready for publication. We don't grab all electronic health records for those set of patients that we've identified as part of the data pool. Rather, we grab records starting from January 1st, 2018 and later, which gives us a little bit of historical context about those patients, but not their full electronic health record history. That could be something that you might want to keep in mind as you're working on the data. So if you're looking for a condition, for example, that might be diagnosed in a patient 10 years ago and then never show up again in their electronic health record for one reason or another, we might not actually see it in our data. The second row of this dashboard shows some summaries of a few of the tables that are defined by the OMOP data format, and you can see we've got lots of yummy data available. All right, so even that's not quite the whole story. Not all researchers will need access to every patient details. So we've set up three levels of data inside the enclave, and these levels have different access requirements. Apologies for the small text on this slide. This is actually from a governance page, and I didn't really want to take the liberty to paraphrase it. So I'm just going to reproduce it exactly. The most complete data are the level 3 data, also known as the limited data set or LDS data. This is the rawest form of data that we make available to researchers. It does include 2 protected health information fields defined by HIPAA. Those are the dates of service and accurate patient zip codes. But it doesn't include many other identifiable information fields like names or birth dates and so on and so forth. Level 2 data or de-identified data are the same thing, except the dates of service have been randomly shifted, plus or minus, and zip codes are truncated to 3 digits for added protection. That actually makes those particular protected health information fields no longer protected health information according to the HIPAA standard, and that allows us to put different access controls on them. If you're worried about this date shifting being algorithmically shifted, making it very hard to do any kind of analysis, there's good news here. The dates of service are algorithmically shifted on a per patient basis. So for a given individual, all of their dates will be shifted by the same amount, meaning it's still possible to go into this data and say, hey, I need to identify everyone who had a COVID positive lab test and then within 10 days found themselves in a hospital room or something of that nature. And then finally, there are the level 1 data, also known as synthetic data, and these data are a bit different. Rather than actual patient data, what level 1 data contains are data derived from the level 3 data via a statistical model. And then we simulate or synthesize data from that particular statistical model. While the level 2 and the level 3 data are in that OMOP format that I mentioned, the synthetic data are in a simpler single table format that's been pre-processed depending on the information of interest. So when you generate this synthetic data, you actually pick some fields from the level 3 data that you're interested in for your particular research question, and then the statistical model is built over those specific subset of fields rather than the entire data set, and that helps with the synthetic generation process. These 3 levels are available to different classes of researchers. So reading from top to bottom here, the level 3 data is only available to those at US-based research institutions. And the level 2 data is also available to researchers from foreign institutions. The level 1 data is additionally available to citizen scientists, that is to say, those without any affiliation with any research institution. And that's a really fun kind of thing for community engagement and getting more scientists from the community involved in N3C. We have a couple, in fact, high school students who are actually accessing the level 1 synthetic data as citizen scientists and doing some fun projects. So even the level 1 data, however, does require some hoops to jump through to get access to it. And there are three sort of major steps as part of this. The first one is to get registered with N3C. And then the second one is to, after you get registered, actually get access to the data enclave with your registration account. Once you get access to the data enclave, you can complete what's known as a data use request or a DUR, and that's how you actually get access to one of the level 1, 2, or 3 data sets. There's some prerequisites for this second step and the third step. In particular, for the second step, you need to be covered by what's known as a data usage agreement, which is a legal document that's executed with NCATS, and we'll talk about that in a minute. And then to actually complete the DUR, you need to have completed some IT security training, which is linked down here in the N3C governance. So you can find more information about all of these steps at this link down here. The level 2 data, in order to get access to that, it's pretty much the same access process. However, you also have to have completed a human subjects research protection training and have the completion date handy for your data use request submission. And it needs to be within the last 3 years. And so that's often completed by like the city program or some other partner of your research institution. The level 3 data have all the same requirements, but in addition, you'll need to have a local IRB approval of your project, and then you can submit their determination letter along with the data use request to get access to the level 3 data inside of the enclave. So mostly we're going to talk about the level 2 and the level 3 data. Most of our researchers are interested in those particular data sets. But before we go there, I wanted to give a quick summary of that synthetic data, that level 1 data. So this is a screenshot of a synthetic data table, which I got special permission to show you. Generally, screenshotting or showing in a recorded webinar row level N3C data is a no-no, even if it is that synthetic data set. So don't take screenshots or record. I've got special permission to show you this particular example table. Again, what's interesting about this table is that it's created with a specific question in mind. In this case, evaluating COVID along social factors like income and poverty. And there's just one table that's provided along with this synthetic data set because it's been pre-processed for that particular question. The statistical model generating those data aren't built from all of the level 3 data, as I mentioned, just some particular columns or fields of interest. And so synthetic data also comes with some quote unquote release notes describing sort of what data went into that synthetic generation process. And here's an example of what those release notes look like. This synthetic generation process is handled by a private company known as MD Clone, and they've kindly provided us with some links here sort of describing how it works. I don't know if I mentioned it, but we'll be able to get you guys access to these slides so that you can follow all these links after the fact. You might be wondering how accurate this synthetic data generation process is. Don't worry too much. N3C actually has a team of folks known as the synthetic validation group who are working on exactly that question to sort of evaluate whether or not a research project completed on some synthetic data ends up generating more or less the same results as if you had run the same research question on the level 3 limited data set. And preliminarily, a lot of the results are really good. The synthetic generation process works quite well, though again, this is very determined based on the particular source information that is chosen to go into the statistical model of interest. Before we get back to talking about the data, I wanted to dig into the DUA and the DUR business because it does trip a lot of folks up. The data use agreement is sort of outlines the do's and don'ts. You do need to read it, but includes things like, this data is only for COVID-related research. You mustn't try and re-identify any patients or share any data. And oh yeah, your actions inside the enclave are logged. Data use agreements are often signed not by individual researchers, but rather by their institutions. So for example, I'm at Oregon State University, and Oregon State University has signed a data usage agreement, which means that anyone at Oregon State University is covered by this data use agreement. Quite a number of research institutions have signed a data use agreement, and so you can check out this link here to see the list of them to see if you're already covered. And if your organization is not, but you think it should be, go ahead and reach out to us or check us out at office hours, which I'll mention at the end of this. We can help you figure out how to get your organization signed up. Usually it's involved with getting a hold of your research office or another similar office to get that process started. For citizen scientists who don't have an organization to sign up for them, they can sign the DUA themselves directly with NCATS. As I said, we do have a few folks that have done this, including some minors who have signed, or rather who are accessing their parents' account, and their parents have signed the DUA process. And it's basically a PDF that you fill out and email to NCATS, and then they sort of email you back and say, okay, good job. So at the end of the day, getting access to the enclave requires first registering with N3C, and then someone will sort of confirm that your registration has been covered by a data usage agreement, either by matching up your account email with an institution that has a DUA, or by matching up your account email with like a citizen scientist DUA or some other sort of matching between your account email and the DUA that is on file. When that happens, you'll get an email with login info, or you can go directly to the enclave at unite.nih.gov. However, although you'll be able to log into the enclave and the 3 levels of the data are stored in the enclave, getting access to the enclave doesn't automatically give access to those data levels. There's a data use request process that's in the middle. But the way that it works, I think a little bit more cleanly to describe it, is not so much that you get access to the data, but rather there are research projects, which you can think of as folders. And those research project folders get access to the data as configured by the administration and the backend folks at N3C. And then researchers get access to those particular projects, thereby through there getting access to the data. Now, getting access to a project or creating a new project and then getting access to it requires filling out that data use request form, which actually happens inside the enclave. You can think of each project as being associated with a single data use request, or DUR, which specifies things like, what level of data is being requested for the project, what's the title of the project, what's the abstract of the project, what's the rationale for why the project should get access to this or that level of data, and so on and so forth. And then all the researchers who want access to that particular project sign on to that same data use request. And only the first person or the lead of the project specifies the title, the abstract, and the level of data that's being requested. These data use requests are then reviewed by a data access committee before project access is granted. So everybody gets their application reviewed by the data access committee to make sure that they're sort of a real valid person with a good reason to access that particular project. With all of that said, we assume you'll want to start playing with data and tools as soon as you can log into the enclave. So we've also included some publicly available data in that OMOP format, known as SynPuff data. Even though it's called SynPuff data, which is short for synthetic public use files, this is sort of notional data. It's fake data, if you will. But it shouldn't be confused with the level 1 synthetic data, even though they both have the word synthetic in their title. And we actually have a new version of some notional data coming online, which is a little bit more complete and realistic. It's not quite ready for prime time yet, but before too long, I'll be updating these slides to note that we have a new notional data set available that looks a little bit more like the level 2 and level 3 data. Okay, so we're still in a little bit of a boring part of this presentation where we're talking about access and rules and regulations and so on and so forth. I do want to mention a few other rules of the road while we're on the topic. So there is a user code of conduct, and that's one of a few different governance documents which can be accessed down here at ncats.nih.gov. The user code of conduct, you should again go read it, but to briefly summarize it, it says things like this is for COVID research only, so any other questions you might be interested, you'll have to wait for another enclave. Follow all the laws and regulations, obviously don't attempt to re-identify people Also do an attempt to re-identify institutions or populations. So we have data from lots of different institutions, but we'd prefer not to identify which institution gave which data. Don't take any screenshots of data or results, and don't record video calls that show low-level data. Video calls that show data are okay if everybody on the call is approved and has access themselves. So for example, if you're working on a project and everyone has filled out the DUR and has access to the data via their own means, it's okay to share that in a Zoom call or something. Do publish, do attribute N3C properly, which you can find some links to as part of the link up here. And then if there are any data access incidents, you can report those within 2 business days. And again, you can find out details on how to do that via this link up here. We also have some community guiding principles, talking about things like our, sort of values of partnership, inclusivity, transparency, reciprocity, accountability, and security. And that document includes some guidelines on ethics and diversity and inclusion, as well as resolving issues through community arbitrations that anything sort of seriously bad happen. And there's an issue that you want to bring up discreetly. Also of interest are what happens when you get ready to sort of publish, or you have results that are produced in the enclave and you want to start showing them off to the world. There is a publication committee, and they review publications that people want to produce based on the N3C data. And that covers pretty much everything from, a poster or a conference abstract to a paper that you want to submit to a journal. You should tell the publication committee about your publication. If it's a paper, do it before you submit it. But if it's a poster or abstract, you can do it sort of after it's been accepted. Do note that because you can't screenshot or record, if you want to actually take in results and put them in a paper or a poster or an abstract or something like that, you'll need to export them from the enclave. And there's a review process that happens. You sort of package up the thing that you want to report on, and then you submit it for review, and then a committee will look at it and say, yes, you haven't leaked any appropriate data, and yes, your publication matches what you said you were going to do in your data use request form for your project, and so it's good to go. Basically, the summary here is that if you're going to produce a figure or a table that has information about it, you shouldn't have any quote unquote cell sizes of between 1 and 19. So if you're producing a table and a particular table, cell covers 20 individuals, let's say it's an average of 20 individuals or 21 individuals, it's okay. If it's produced over 15 individuals, then you just sort of have to say it's less than 20. 0 is an okay number as well. So you might say there's nobody that had this particular set of conditions, and that's all right. So there's some more details about these things at the publication review. And then inside the enclave, we have a training portal, which I'll mention briefly, and there's some more information about that as well there. And then another thing to mention, sort of along the guidelines, and so on and so forth, is there are often questions about external, what we call external data or supplemental data. So for example, information that's derived from the census or other publicly available data sets that you'd like to use along with the EHR data that N3C has. And this is doable, but because it could present an extra risk for patient re-identification, there's a process to it, like most other things. So external data sets like these need to be reviewed for security and license, and then they get uploaded to the enclave for you by someone with administrative access. The good thing is that once someone has gone through the hoops to get an external data set uploaded and put into the enclave, it's available for use by everybody in the enclave. So there are already like a good number, I think 20 or 25 different publicly available data sets that others have found useful that are available for you to use in the enclave along with your research. In order to actually get access to them, you have to go to a particular spot and acknowledge the risk that your institution might consider this to be something that you have to check by an IRB or something like that. So you have to sort of say, yes, I understand that my institution might have extra special rules around data linkage that I need to follow. So there's more information here on this particular link. And again, inside the training portal, which I'll mention in a moment. All right. So before I move on to a little bit more fun stuff, I wanted to take a quick pause and see if there are any questions. I don't see any in the Q&A, but if you happen to have one, now's a good time. I'm going to take a brief moment just to catch my breath and see if anyone has any questions about what we've talked about so far.
To ask them live, if you just raise your hand, I can click you and unmute you.
Thanks, Al. Should really have some water handy when I'm doing these. Okay, I don't see any questions at the moment, so I'm gonna continue on. We've got lots of other good information to get into. So we've talked a lot about this data enclave, and let's actually take a look at what it looks like once you're able to get logged in. I don't know if anyone on this call has not yet been able to log in yet, but if not, this is what you'll see when you do log in. Here's our dashboard that I showed earlier. It's a little bit older screenshot. I do want to point out a few things on this, what we call the Enclave homepage. The first one is sort of how to get help. So N3C has a variety of different mechanisms by which you can ask questions and get help. And we set them up because there are lots of different processes that are confusing and you have to jump through them. But where you ask for help for a particular question kind of depends on what that question is. So if, for example, you have a question about some particular patient data, or you have a question about some analysis or a code package or something of that nature, those questions might actually contain protected health information that we prefer to keep secure inside of the data enclave. So if you have a question about the data itself or about the analysis of the data, then you can ask that question in the enclave. And actually, you can go and ask that under the help and support menu down here in the lower left, and then there's a submit an issue question, and then you can submit your question there and somebody will look at it. On the other hand, there are lots of other questions that you might have about N3C. Hey, my data use request has been waiting for a long time and the data access committee hasn't looked at it yet. Can someone take a look at it? I can't find the documentation about X, Y, or Z. I can't get access to the enclave, questions of that nature. Obviously, you're not going to ask a question about you can't get access to the enclave inside the enclave. So we have a external help desk and outside the enclave help desk, which is linked to down here. And that's appropriate for pretty much all questions that aren't about specifically the data and the analysis. So I do recommend that you check out that particular help desk for most of your general questions. And that's staffed by well over 20 people who are trying to keep the timeline to answering questions down. If you're not sure, however, which avenue you need to go to and you have enclave access, you can go to the support and contact button here, and it basically just reiterates what I just said. Go here for these kinds of questions, go there for those kinds of questions. This button here takes you to a bunch of documentation and training materials, which are excellent. One of the things that's inside there is the training portal, which includes a bunch of what we call training modules, many of which are specific to N3C and our data and how to work with it. And so there's a lot of good information there that will get you jump started in your actual analysis and project. So do check out the training portal inside of there. These three buttons deal with the data use request process. So that's how you can go and see the projects that others have created and try and join one by filling out the data use request for that project, or create a brand new project along with the data use request that goes with it, and so on and so forth. There's more information here than we really have time to cover on this whole DUR process and the different tools that are available for it. But you can go and you can check out there's a video called Enclave Organization, which I think the title is slightly different on this page, but there are some videos here available that talk about the DUR process and what's involved. While we're here, I'm going to notice over on the left navigation panel bar, we have some tools for analysis, and we're going to talk about those just real briefly. And then up here, of course, there's the projects and files link, which will show you the various project spaces and folders and things that are contained within the enclave. I see that there's a good question in the Q&A. I'm going to answer it live. If I was interested in assessing genetic factors regarding COVID-19, how would I go about doing that? Or is this data set more conducive to studies answering social demographic questions? That's a really excellent question, and I don't know that it's covered in this presentation officially, so I'll answer it now. So the N3C, the primary N3C data that we have are electronic health records, stuff that is reported from hospitals and that patients give to their doctors and go into Epic or whatever. We don't generally have genetic information for patients. We don't generally have, for example, imaging information for patients. So we don't have chest x-rays, stuff like that. And there are a variety of other information about patients that we don't yet have. That said, there's a lot of interest in gathering this information, and there are teams working on that, including the genetic information set for patients. What's required for that is that we're able to sort of securely upload those information from different sources, and yet nevertheless be able to say the data for this patient and the data for this patient are actually talking about the same patient without identifying who that patient is. And so that sort of linkage, that anonymous linkage, is still being worked out, and the legal forms and processes are being worked out for it. So I will say that there are teams working on getting in genetic information as well as all kinds of other patient relevant information so that it can be linked to the primary EHR data, but none of that is available quite yet while we figure out those linkages. So I wouldn't say it's necessarily conducive to answering social or demographic questions. It's really conducive to answering stuff about the electronic health records. So which drugs are effective, what kinds of treatments are people being exposed to, and those kinds of things. And social demographics are also possible because we have a lot of social demographic information from those external data sets like census and so on and so forth. But for other patient information, we gotta figure out the linkage between those. Okay, so continuing on with some screenshots of the enclave. If you were to click on this projects and files link, you'd see sort of the project folder browser here where you can see the various projects. Many of these are research projects. So for example, RPO7A7C4 retrospective identification modifications. That's a research project. There's a DUR associated with it. And you may well be able to access that particular project by connecting up with the lead for that particular project and then getting access to the project by filling out the DUR for it. However, in order to do that, don't use these big request access buttons. These are just vestigial in the interface, and they're not connected to that whole DUR process. So if you were to try and request access there, it would just tell you where to go to actually request access. And the short answer is that you go back to these buttons, and that's how you request access to a particular project. But you can browse through the projects via this particular interface. Under the projects and files, we saw the projects tab. There's also a data catalog tab. So data sort of naturally lives in these project folders, but project folders can have lots of other folders and analysis files and temporary stuff in them. And so it helps to have a place to sort of curate links to common data sets that are easy to find and navigate. And that's what the data catalog is. And so if you go to the data catalog, and you have, for example, access to the level 2 de-identified data via one of your projects, then you'll be able to go to the data catalog and check out the de-identified data collection and see just the tables for the de-identified data, and then you can browse around them and use them in your project. There are some other data catalog collections that are useful. So dashboards and apps, for example, has various dashboards and extra applications that are used for working with N3C data. There's some tutorials and other external data sets and so on and so forth in this data catalog as well. It's a really handy place to go to look for stuff. Moving on to some analysis tools. This is a screenshot from Contour, and I'm showing a screenshot of some of that notional SynPuff data, so there's no patient data being leaked here. Although this is a graphical data analysis tool and hardcore programmers might be tempted to turn up their nose, there are some good reasons to actually get familiar with this tool, even if you're like an expert in Python or SQL. The first one is that it's rather powerful. You can do lots of joining and filtering and date arithmetic and all kinds of stuff like that. And so it can do pretty large subset of what you could do with SQL or Python or R. The other thing that I really like about it is it knows how to efficiently work with 5 billion rows of data. So the amount of data that we have in the enclave is really large, and you get into this big data space. And that can be kind of a headache when you're working in Python or R or SQL, and you have to start looking at specialized libraries. For the coders in the room, most of what happens in the enclave is backed by Apache Spark, which is a high-performance distributed computing framework. And so if you're working in Python or R, you may need to find that you need to work with the PySpark library in order to actually be effective with the data. Contour is automatically backed by Spark, and you don't really have to worry about it nearly as much. The other thing that I really like about Contour is that you can do your data filtering, your data joining, your basic data arithmetic to clean up your data and get it ready for the statistical question or whatever it is that you're interested in. And then you can save the result of that filtered data set in your project folder as a much smaller data set. From there, you can bring it into Python or R or whatever to do your statistical analysis, and you don't have to worry about that Apache Spark so much because the data have already been filtered down to a much smaller size. That'll be more comfortable for you in those particular tools. So speaking of code-based tools for Python, R, and SQL, we don't have Jupyter notebooks, but we do have what's known as code workbooks. And this is kind of a really interesting hybrid interface for writing code in a graphical environment. So what we're seeing here is every sort of node in this computational graph is either a data table that's been imported to the code workbook, or it's a Python or R function or a bit of SQL code that takes one or more tables as input and produces one or more tables as output for another sort of node. They can also produce graphical visualizations sort of along the way as a side effect. And so it's a pretty neat and powerful tool for doing code-based analysis inside the enclave. There are like 5 other useful tools that we don't have time for in this orientation. There's a reports tool where you can sort of take tables and visualizations and put them in a nice, easy to read report for your PI rather than having to send them to an interface like this. There's a spreadsheet-like tool, sort of like a basic Microsoft Excel kind of thing, which is useful for typing in small data sets by hand, your particular codes of interest. And then you can load those up into another tool to analyze them or to use them in your analyses. And there are other things too. Okay. I'll pause real briefly to see if there's any questions so far, and then we'll get into talking a little bit more about OMOP. Going once, going twice, going 3 times.
We have a question. Sorry, give me 1 second. Too many things are open. Oh, I'm not host. That's why I can't do it. John, if you click on Ray, you should be able to, in the attendees, participants.
Got it. Hey, Ray.
There you go.
Hey, just a quick question. So just in terms of, if we are like, in the process of, writing a paper or, submitting for, a poster or something, and are all the figures like tables, actually the display of figures has to be generated within the enclave? Or can we, we have, used in the past other graphical, software to design figures, and there's different ways we want to plot the tables. And are there mechanisms to get the, not the row level data, but the aggregated data and, post analysis data, right? Summarize statistics and all those stuff, p-values and confidence interval, get that level data out of the enclave, and then do the, making tables and graphs outside of the enclave, or that everything has to be done in the enclave?
I think you can do that. There are tools for formatting tables and graphs inside the enclave, but if you have an aggregated data set and you can get it through that export review process, right, where you guarantee that it hasn't released any small cell sizes and stuff like that, I believe you can get it out as like a comma separated value file or something that you can load into Excel or another tool, and then you can do your own generation from that. So so long as the sort of what you're exporting passes review, I think you should be okay to work with it more outside of the enclave.
I see. Just to clarify, just I see two ways. One is kind of using every other tools, display, graph, figuring, making tools within an enclave, or get that aggregated data, send that through the review first, and then export it, and then kind of make your own figures outside of the enclave, right?
If your aggregated data is like 10,000 rows or something, the review committee might go, so not a way to do this inside the enclave or something like that. But I believe that, yeah, I don't see any issue, at least offhand, that I know of, with sort of doing some data aggregation, exporting sort of a raw, not quite polished up, ready for publication version, and then doing your extra analysis afterward, or your data viz or whatever.
Got it. Yeah, thank you.
Yep. Okay, so we're going to talk a little bit about OMOP. I don't know if there are folks on the call who are not familiar with OMOP, but this is the primary common data model that the level 2 and level 3 data are in. And I want to talk a little bit about it and why we went with it. So OMOP is short for Observational Medical Outcomes Partnership, which is a project which actually expired back in 2013 to address this problem of interoperable health data. And they did a lot of things, but one of the things they did, and probably it will appear the most enduring thing that they did, is came up with this particular way of organizing, formatting data that turned out to be really useful because it can ingest data not just from sort of like different raw sources, but from other common data models, and it preserves the provenance of those information. Since 2013, it's been stewarded not by the OMOP group, which the funding expired for, but rather the Observational Health Data Sciences and Informatics Collaborative, or OHDSI, which is pronounced Odyssey. This is a worldwide group of folks who really care about sort of data sharing and common data models and doing electronic health record research the right way. So OMOP's design, if you're familiar with other data models that are more designed around billing or something like that, OMOP might be a little bit weird for you. I actually only have experience with OMOP, so I can't really give much insight into what the weirdnesses might be, but there is that. And by default, the OMOP common data model defaults to try and exclude stuff that's not generally useful for research except for where it's warranted. So you probably won't find names, for example, in an OMOP database. The data tables, the domain tables as they're called, are person and event centric. So most of them have a row which indicates, the person that particular record is about and the date that the thing happened on. So, the date that they got the drug, the date that they started the drug, that they ended the drug, the date that the observation occurred, and so on and so forth. And that makes it really convenient for analysis. Here's a real quick screenshot of the drug exposure table from that SynPub data set, just to give you an idea of what this sort of thing looks like. So there's a column for the person ID, that's an identifier for which person it's talking about. There's another table called person, which will give demographic information about person 4, person 5, person 7. Drug exposure ID, this is just the unique identifier for every row in this particular table. Drug concept ID, this is a really important one. Columns which end with concept ID are really important ones, and they describe the actual numeric code for the drug that particular patient got. And then, of course, we have things like drug exposure start date, drug exposure end date, and so on and so forth. Further down in this table, there's a column called drug concept name, which is the human readable name for the drug concept ID. But generally, you're going to use the numeric ID much more than you're going to actually use the human readable name, because human readable names may or may not follow any kind of standard or assumptions that you might have. To talk about that a little bit more, OMOP concepts are actually leveraged from national industry standards of vocabulary. So OMOP didn't decide that they needed to invent any new vocabulary terms. There are plenty of them out there, whether you're dealing with ICD-10 or SNOMED or ICD-9 or so on and so forth. However, OMOP does give every vocabulary term from all of these different vocabularies its own OMOP specific identifier, and those are the concept IDs. So 35207-956 is the concept ID for pneumonia, which is the match for J18.9 from ICD-10, for example. OMOP data values, the originals from the source data partners are kept. So if you're curious to know how a particular record was coded at the source data partner, there's a column for source concept ID and source concept name, and you can go and look at those. But as part of the ingestion harmonization process, all of those are actually mapped to a set of standards identified by the OMOP community for the actual analysis. So for example, if you're talking about pneumonia, there's probably 10 different ways to code pneumonia across the ICD-10, ICD-9, SNOMED, and so on. But the OMOP folks said, you know what, for pneumonia, we're going to consider the SNOMED code to be the standard that we're going to use. So if someone came in with an ICD-10 pneumonia diagnosis in their source, we're going to map it to a SNOMED one. And that's really handy because amongst at least the standard terms that OMOP has identified as which ones are standard, which ones are not, most of them come from SNOMED, but there's no hard and fast rule there. There's a hierarchy available. So for example, there's a term that's a standard for Proquin XR, and there's a term which is a standard for ciprofloxacin 500 milligrams, and there's a term which is a standard for the antibiotic. And there's information that basically says that Proquin XR has ingredient of ciprofloxacin 500 milligrams. And there's a relationship between that standard term and the standard term for antibiotic as a ISA. So this defines sort of a hierarchy amongst all these things, allowing you to define what's known as a concept set. So you can say, all right, I need to go in and I need to find all of the drug exposures to ciprofloxacin, no matter what kind of drug they were, no matter what kind of dosage they were, so on and so forth. You can go in and you can identify all of the concept IDs for drugs that contain ciprofloxacin by looking at this hierarchy and defining a set of the concept IDs that you're interested in. And then you can take that set and match it against the actual data to identify all of the exposures to, say, ciprofloxacin. So this idea of a concept set is pretty important. You don't have to do this all manually by hand by sort of navigating this massive hierarchy of 5 million different terms. There's some really great tools that have been developed by the Odyssey community, as well as a few that have been developed, that we developed specifically for N3C to develop these concept sets that cover all of the things that you care about and none of the things that you don't. So for an overview of this sort of process of developing a concept set and using it in the enclave, you can check out inside of the training portal. There's an intro to OMOP and contour video I put together. It's about 45 minutes, and it really covers some of the important basics. I'd recommend you check it out. Speaking of concept sets and some of the tooling that exists inside of the enclave, so there are some tools that N3C has developed to work with this data and then make them available. One of them, for example, includes the concept set browser. So it's possible to define your own concept sets. Maybe you're interested in ciprofloxacin or drugs containing ciprofloxacin. When you create a concept set, it goes into sort of a pool of concept sets, and then you can go and browse all the different concept sets that have been defined by others as well. And you'll notice that there's some reviewing information here. So N3C cares quite a lot about community research and reproducible research. And so we try to include tools that make it possible for peer review of these different resources so that you can use them and have some idea of the quality of them and have them reviewed by experts. So that's enough about OMOP in general. Here's some links to some other information about OMOP. There's the Book of Odyssey, which covers sort of the history of it as well as a pretty in-depth technical guide. Eden Academy has some really great longer form online courses. There's other Odyssey tutorials. And then there's often a question about, okay, what columns are in the tables and what tables actually are there? I like this particular view. This shows the tables and the columns and the definitions of what's in those columns in a fairly user-friendly, browsable form. So this is a handy link that I tend to go looking for myself quite a lot. So I thought I'd just put it directly in the orientation. Okay, so that's OMOP in general, but then of course we have OMOP as used by N3C, right? Where we actually take the data from lots of different common data models from our data partners and then harmonize it into one single OMOP model. But it turns out that this is really complicated, right? Because all these different data partners come with their own caveats and interesting issues with their particular data. And so the data harmonization and ingestion teams work quite hard to produce high quality ingested data by making sure that the different units are all harmonized to be the same kinds of units, look for outliers across the different data partners, so on and so forth. And Devera Gabriel at Johns Hopkins is someone who works on this particular team, and she's really amazing. You might run across her. She knows quite a lot about the data, as do a variety of other folks on that team. And so some of the issues that we get, aren't necessarily fixable, and this is just a consequence of our data partner model, right? Death data is a really good example of this, right? So when we have a data partner who's using OMOP and we bring their data into OMOP, then we're pretty sure that we have good death data if they have it at the hospital, right? They may not if the patient didn't die at the hospital, but in any case, our data partners who are already on OMOP support including death data, and they support requiring that death date and the cause of death. So we get that information from there. However, our partners that are using PCORNet don't require a death date, and so some of our data partners have information about data death, some of our data partners don't have information about data death. Just depends on whether they collect and use that. And some data models that we partner with don't even have the ability to support some information. And so you'll see across the different data partners that some information is sort of systematically missing, and death data is a really good example of this. So some other sort of caveats to the data, I mentioned it earlier, but identifying, what is and isn't COVID is something that can be tricky. There are a lot of different test types. There are a lot of different ways of encoding the results of those tests, whether it was elevated or high or whatever. And then of course there's the diagnosis code. Fortunately, we do have some shared resources that are available so that you can sort of go in and say, okay, I need to get some COVID positive patients. I want the PCR results, not the antibody results, and I'll also include the diagnosis code or something like that. So we have some of those information available. This is an interesting slide. I can never tell if it does what I'm hoping that it does, but essentially what happened is there was a symposium earlier this year, and as part of that, the runners of the symposium did a straw poll amongst some data partners and some research teams to sort of say, hey, research teams, how high a priority are some of these different things that you might find in the data? And then data partners, how difficult is it to actually put together some of this information? And you can see that, the main thing that I want to show here is that it's not always a one-to-one match. Stuff that you might think is interesting, it's not necessarily easy to grab from the data partners. And some of it is not easy to work with purely because OMOP doesn't make it easy to work with, or the source data doesn't make it easy to work with. Pregnancy status is a good example of that. The pregnancy group has had to work quite hard to identify all the patients who are pregnant and when they were pregnant, because there's 1,000 different ways to identify pregnancy. First trimester pregnancy, third trimester pregnancy, various different kinds of things. And it was a little bit of a challenge to get together the concept sets that identified pregnancy. So because there are differences amongst these data partners, we do have a column in all of the tables known as the data partner ID. And this identifies for every row in the data which data partner it comes from. It doesn't give the actual human readable name of that, like this data came from Johns Hopkins Medical Center. Rather, it's encoded as a pseudo-random numeric identifier. So you can't tell who had which data, but you can say, oh gosh, I noticed that there's no death information for data partner 732 or something like that. And so this is very handy. You might want to use that particular information to break your analysis out by data partner ID to look for issues of systematic missingness or differences between the data. Those are just sort of a handful of some of the persistent data issues that we see. And if you want, you can go and check out inside the enclave this link here, which will list the known persistent issues that are just involved with the data harmonization process. That said, there might be issues that you notice that haven't been noticed by others, just because you got into a particular corner of the data that others haven't looked at yet. And so if you do notice something strange in the data, be sure to report it as an issue inside of the enclave. You can do that under the help and support and then report an issue. That's also where you go to ask questions about the data or analysis. And so you can go there and say, hey, I noticed that this data partner site doesn't have any of this particular class of drugs. I thought it was weird. And then someone on the data ingestion or harmonization team will sort of say, yeah, we know about that. We're working with the data partner. or they'll say, hey, this is brand new. Thank you so much for letting us know.
Just as a reminder for folks, there's a kind of a generic or a generalized synthetic.
Weird. Okay. So just to wrap it up here, we're getting close to being done. We've talked a lot about data, but of course N3C is a lot more than just data, right? It's a community. It's a really great community. It's a really big community. I'm really proud to be part of it. We've got over 2,200 registered users with N3C now. Over 1,300 folks are logging into the enclave or have logged into the enclave. 160 research projects have been created associated with those data use requests. We now have 190 plus institutions who have signed the data usage agreement, meaning that that's everybody at those institutions doesn't have to worry about signing that particular legal form to get access to the enclave. And although we only have 50 data partner sites with data in the enclave right now, there are over 85 data partners who have signed the agreement to transfer the data. So we're expecting another 35 or more, probably more sites to ingest their data, and our data will continue to grow as those come online. Communication is really big in N3C. The Slack workspace is pretty active. Good place to ask, for general questions about how do I do X, Y, or Z in the enclave. That's been a handy place to go for those kinds of things. Google is used pretty broadly by different research teams and so on and so forth to organize themselves and do communication. And just in case you don't have enough meetings on your calendar, there are well over 20 regular weekly meetings that you can sign up for, depending on which area of all of this you're interested in. And so just to finish up, I think it's handy to have sort of a mental map of all the different organizations of N3C. And I'm going to preface this by saying this is my personal mind map of how N3C works. It's not been reviewed. It's the unofficial version, but it helps me sort of keep all the pieces straight here and there when I can. So when N3C started, we identified 5 different sort of important work streams. There's the data partnership and the governance work stream, and then there's a work stream just for that synthetic data, working with the synthetic data, validating it, and so on and so forth. Collaborative analytics, that's where most of the actual research sort of falls under that umbrella. Phenotype and data acquisition and data ingestion and harmonization, those are the parts that work closely with the data partners and get the data actually inside the enclave. Within these work streams, there are a variety of different teams and committees and so on. So we mentioned the publications committee, they kind of live, at least in my mind, under the data partnership and governance. There's some project management and admin teams and things like that. The synthetic validation working team lives sort of under the synthetic data workstream umbrella. And then, of course, we have things like research projects. So this is a hypothetical research project that I sort of invented, hypothesizing a research group who's interested in studying heart disease and COVID-19, and they might spin up a research project. And that kind of lives under the collaborative analytics umbrella because it's an analytics kind of thing. What's really cool, however, about the collaborative analytics workstream is that there aren't just research projects, there are what are known as domain teams. And domain teams are sort of umbrella groups for multiple potential research projects along a topic or theme. So for example, there's an immunosuppressed and immunocompromised domain team, and then under that include a potential of multiple different research projects. So a research project that's focusing on HIV and COVID, and then another one that focuses on autoimmune skin disorders and COVID. Under diabetes and obesity, there might be one or more different projects sort of underneath that label. And this is a way to sort of organize teams in a way that makes them sort of, puts them close together and then has them meet, and you can exchange information and learn about what's going on and sort of facilitate collaborative research in the enclave. So those are the clinical domain teams, which are sort of generally involved around a particular clinical research question, but we also have cross-cutting domain teams. And these are domain teams that tend to be a little bit more methods focused. So there's a machine learning domain team, and they have a variety of different projects going on around machine learning as applied to this kind of data. There's a genomics domain team and so on and so forth. And the idea here is that we hope that these domain teams will also make their skills available to other domain teams to sort of infuse machine learning throughout N3C where it makes sense to do so. So that's one benefit of sort of joining a domain team, is that you get sort of plugged into existing research groups and get some facilitation of communication going on. Another useful thing about being in a domain team is that we have a team of folks who are known as data liaisons. These are people who are on those phenotype and data acquisition and data ingestion and harmonization groups. So they work with the data partners and they know the data really, really well. So if you have questions about OMOP or how to generate a particular concept set, or, you know, is this the right way to look for that particular drug, or so on and so forth, the data liaisons group is a really great resource. Now, because they're sort of a precious limited resource, they're not available to all research projects. Rather, they primarily support research projects that live under domain teams. So every domain team has access to a data liaison. Domain teams also have access to some project management and administration help. So, you know, getting the calendars together, setting up the Google groups, stuff like that. So that's another really good reason to plug into this sort of like domain team architecture, is that there are more N3C supports available to research projects that live in domain teams and collaborate with other projects under domain teams. So that's it for me for right now. Your next steps, you know, if you haven't done so, do check out the resources that we discussed today. Go ahead and get registered. Hopefully you're covered by a DUA and you can log in. Go check out the N3C website, especially go check out those domain teams. There are a lot of domain teams and your particular research interests might already be represented, but there might not be a research project about your particular research interest. The leads of the domain teams are all super friendly and they're there to help sort of facilitate research underneath their umbrella domain team. Access the Enclave and browse around, especially that training portal. Like I said, there's some really good information in the training portal, including these orientations and some other how-tos and getting started kind of things. And of course, come back next week for orientation session B, where a colleague of ours, Saad, will talk about a little bit more in depth on using code workbooks, using Contour, using the concept set tools to do the technical things inside the Enclave and get research done. Whew, and that's it for now.